the telephone. In the real world, this device is so common that we don't give it much thought. But in a video game, they can help drive the story, give the player some off-screen guidance, or simply be used to hide Easter eggs. So in today's video, we'll be creating an in-game phone system that includes real-world accurate dial tones, DTMF tones, a busy signal, and a ringout tone. And we'll be creating them without using any pre-recorded assets, meaning they'll all be generated directly in the engine. So with that being said, let's get started. As I mentioned, we're not going to be using any pre-recorded audio assets. Now, I do have a pre-recorded message for the answering machine, which is unavoidable, but in terms of the sound that the phone itself is going to be making, there are no audio assets being used. You will see that I'm using MetaSound patches, which if you missed my video on how to create MetaSound patches, you will see a card that'll pop up here in the top right-hand corner that will walk you through that. But if we look into these MetaSound patches, you'll see that I'm actually just using sine waves, because that's in actuality all that the phone companies use for touch tone phones. Now you don't have to worry about pausing and going back. We're actually going to be building all of these from scratch, but I just wanted to go through and show you that there are no wave players in here. This is all being done with sine waves. The only difference is how the sine waves are being handled and the frequencies that they're using. Now I do want to mention that the tones that we're going to be using as references are the North American variant. Phones are going to sound different depending on where you live, and so the ones that we're going to be basing it off of are for North America, but you can absolutely adapt these if you're trying to create or mimic the sounds from a different region of the world. Now, since we are going to be using MetaSound patches, which do not play audio themselves, we are going to need an actual MetaSound to test these in. So I'm going to go ahead and create a MetaSound source, and I'm just going to call this MSS_phone. And go ahead and open that up and drag it over here. And so we're not going to put anything in this just yet. We still need to actually build out our patches. And so that's what we're going to do now. I am going to go through these in the order that I feel like the order of complexity, starting with the easiest and working up to the more complex. But if you look down here in your YouTube scroll bar, you will see that I've added chapters. So if there's a specific tone that you're looking for, you're more than welcome to jump to that chapter. And with our MetaSound created, it's time to create our first patch. And the first patch that we're going to create is going to be for our dial tone. So I'm going to call this MSP_dial tone and open this up. Now the North American dial tone is actually very easy to create. So we're just going to go ahead and get two sine wave players. And for that dial tone, the frequencies that we need, one is going to be 440, so I'm going to leave that where it is. And this other one is 350. And you can test this if you go into any DAW and you put two sine wave generators and put those frequencies in, you'll hear that is what the North American dial tone sounds like. So we can go ahead, and we do need some output. And I'm going to run this to a mono mixer 2. And we'll want to give our graph an audio output. And we just need to set this up now with some logic to tell it to turn on and off. So I'm going to drag off of our enabled here, and I'm going to go and get a trigger toggle. And I can route this value to the other enable, and that way I am turning both of these off and on at the exact same time. And I'm going to use my out to sync them, because what creates that dial tone is the beat frequency between these two. And so we want to at least sync their start. That way we know that that beat frequency is always going to be consistent. And we just need to make some graph inputs for our on and off. Now, if you watch the video on creating MetaSound patches, you'll probably already know this, but when we drag this patch into our MetaSound graph, I do want these to be in a certain order. And so I want my on to be first, I want my off to be second, and we do that with our sort order variable here. So 0 is going to be on top. The higher the numbers, the further down the side it's going to be. So I'm going to change that to 1. And that's actually all there is to creating that dial tone. So if we go ahead and open up our MetaSound source again, I can actually come in here and drag this dial tone in, and we can start connecting this. And as you can see, it works. Now, I don't have any triggers set up in my MetaSound graph yet for all of this, but we'll get there. Right now, I just wanted to make sure that we had a MetaSound source that we could test these things in. So the next tone that we're going to be creating is going to be our busy signal. And the busy signal is actually very similar to the dial tone. So we'll call this MSP underscore busy signal. And we'll open that up. Now, when I say that these are similar, what I mean is we can actually come in here and copy our trigger toggle, our 2 sine wave generators, and our mixer. And we can actually paste those right in here. The only difference is the busy signal is actually different frequencies. And for the busy signal, we have 480 hertz and 620. Now here's where things are going to get a little different, because the busy signal isn't just a steady signal, it is a pulsing signal. So actually, before I forget, we do need to still make our output for our audio. Okay, so to create a pulsing sound, we're actually going to be using a trigger repeat, so that we can send a pulsing signal through here. And basically what we want to do is we want to create a flip-flop. So from my trigger repeat, I'm going to get a trigger sequence. And I'm working with on and off, so I only need a trigger sequence too. And we want this first output to turn it on. We're going to keep our initial value on our toggle off. That way it doesn't just automatically turn on when we spawn the phone. And with this, we're telling it when to turn on. And so what I could do is just drag this straight over so that as this pulses, it's pulsing back and forth between the trigger toggle on and the trigger toggle off. And the specifications for the busy signal is it's a 0.5 second on and a 0.5 second off. So in our trigger repeat, we're going to change this 0.2 to 0.5. And that way, every half a second, it'll turn on and then turn itself back off. And we're going to want some graph input controls again, so that we can control that from our MetaSound source. And also, just like before, I'm going to change the sort order of the second one to 1, because once we get to our MetaSound patch or our MetaSound source, I want those input pins to be in a specific order. And so that sort order is what handles that. So I'm going to go ahead and name these accordingly as well. So for example, in here, I don't want these to just be on and off, because that can get a little confusing. So I'm actually going to change this to dial tone on, dial tone off. And then in here, I can call this busy signal on and busy signal off. Now there's one more thing that we need to do to this, because with how we currently have it set up, the busy signal off is going to turn off our trigger repeat. But that means whatever status this is in is going to stick. So if we were to turn the busy signal off while the trigger sequence was toggling this on, then our busy signal would just stay on. I'm going to pull off this a little bit further. And from the off pin of our trigger toggle, I'm actually going to do a trigger any. And I want to trigger any 2. And so now this way, our sequence will turn it off, but we can also use our busy signal off to turn it off as well. And that way, regardless of where we're at in the sequence, as soon as we turn off the busy signal, it stops our sine wave players. And so now we can go into our MetaSound source again, and we can drag in our busy signal so that we can test that. So since we're getting a few patches in here, I should probably go ahead and, at least for testing purposes, create a couple trigger inputs so that I can test both the on and the off. And we'll call this one, just for now, we'll call it on. And we'll create another one that is a trigger. And we're just going to call this off. Now we've got our on and our off so that we can test these. And I'm going to run my busy signal now, do my output. And if we hit play and turn this on, you see that our on and our off work. And I'll go ahead and disconnect all of this because we still have a few more patches to create. So the next patch that we're going to make is going to be our ringout tone. So go ahead and get another MetaSound patch here. Call this MSP underscore ringout tone and open it up. And just like before, this is going to be another situation where we're going to be using a toggle, 2 sine wave generators, and a mono mixer. And with this, the ringout tone is going to be 440 and 480. And we'll go ahead and create our audio output just like we have been. And so for this one, it is a pulsing signal. However, it is a 2-second pulse on and a 4-second pulse off. So in total, one full cycle of the ringout is going to be 6 seconds. So I am going to get another trigger repeat. And I'm going to go ahead and set this to 6 seconds. And I'm going to go ahead and create my graph inputs. So we do need something to start it and something to stop it. And I'll go ahead and rename these real quick. Call this ringout on and ringout off. And again, set this to 1. So we have our 6-second trigger repeat, but like I mentioned, it's a 4-second on and a 2-second off, or I'm sorry, a 2-second on, 4-second off. And so we're going to take this and we're going to run it to a trigger any. Move this up a little bit. So we want our start to trigger what we're going to do, but we also want to keep repeating it when we do it. And what we're doing is we're going to take this, and I want this to turn it on. And then I also want to do a 2-second delay. And then turn it back off. So this part here is what's going to turn it on for 2 seconds. And because we have this set to 6 seconds, after that 2 seconds, this will create that 4-second gap before it starts again. And so now we can go ahead and pull this into our MetaSound source and test it. So we can go ahead and connect this. We can connect turning it on and turning it off and take a listen to that. All right, so we have all of these working so far. And now it's time to create the MetaSound patch for our DTMF tones, which are the tones that play when you press the buttons on a touch-tone phone. So one last patch, MSP _, we'll just call this DTMF. Now, even though this is our most complex one that we're about to build, it does still operate on this whole 2 sine wave generators that we're going to be toggling. So again, we can go ahead and copy and paste these here. And in terms of this one, that's really where the similarities end. Because with the touch tones for the button presses, each button has its own unique set of frequencies. And the way that this works is each button press will have its own designated low frequency and its own dedicated high frequency. And so the way that we're going to do that is we're going to be using arrays. And so we need to get this set up to use various assets. And like I said, we are going to be using these as arrays. So we're going to do a get float. And I'm going to copy and paste this down here. And we can create variables off of this. I'm going to create this variable and we're going to call it low tones. And I'm going to pull it off here, create another graph variable, and we're just going to call this high tones. And so I'm going to put a chart up on the screen here that shows what the frequencies are, both the high tone and the low tone for each of our number presses. But basically we are going to end up with 10 elements in each array. And I want to make sure that all of the elements in my array line up. So for example, an index 0 for the low tone, if I'm going to be using that for my number 0, which you can see on the chart, the low tone for 0 is 941, and the high tone for 0 is 1336. So I want to make sure that since those are the corresponding frequencies for the number 0, that they are both in the same index of each array. And so I do have the low frequencies and the high frequencies formatted in a notepad document, so I can copy them and just paste them in here, and it will automatically apply all those values. And let me just go ahead and grab our high frequencies now and paste those in here. And so you want to make sure that if you're following along exactly, I'm starting with index 0 being for the number button 0. And so your array assets for low tone should look like this, and your array for the high tones should look like this. And since we're using an array, we will need an input telling it what index to get. So I'm going to go ahead and pull off here and get a graph input. And since these are the numbers that we're going to be entering, I'm just going to call this numbers. Now I could pull off here and just run it directly to here, but just to make sure that I'm keeping things tidy, I'm going to go ahead and grab a copy of this, and these will still fire synchronously. And you can kind of see from the nodes that we have there, to continue building out the front end of this, we need to come up with some sort of trigger system. So to trigger our array, I'm going to pull off here and I'm going to create a graph input. And instead of trigger, I'm going to call this press, because that's our button press. And just like we did with the numbers, to keep things kind of clean, we can just pull off that trigger again and use it down here. And now there's a couple different ways that you could handle this from here. You know, it is a button press, so it is going to be a dynamic sound if you want it to be. So what that means is we could set this up in a way that when the player presses the button, it turns it on, and then when they release the button, it turns it off. Or you can set this up in a way to where you decide how long that button press is. And that's how I'm going to set this up. And so I'm going to go ahead and grab our button press again, and we can use that to turn it on, and then do a trigger delay, and say I only want this to be 0.3 seconds, and then we can turn it back off from there. But you'll notice that I did leave a little bit of space here, and that's because while technically this works, it does pop quite a bit. And like I said before, even though, you know, an actual telephone will pop, I do kind of want to mitigate that a little bit. So instead of connecting these directly to my trigger toggle, what I'm going to do is I'm going to get an ADSR envelope for my float. And so on press, I want to trigger my attack, and then 0.3 seconds later, I want to trigger my release. But all I'm using this for is to kind of help calm those pops a little bit. And so in here, I am going to set my decay time to 0. I want my sustain level to be 1. And we're going to make our release time 0.01. And then when we trigger the attack, we can go ahead and toggle that on. And we're going to use the on done to turn that back off. And so now we need to get this envelope into our gain over here on our mixer. Now I could technically run those directly through. That looks terrible. So what I'm going to do is I'm going to promote this to a graph variable. And since nobody's ever going to see this, that's totally fine. We can just leave it as out envelope. And I'm going to drag this over here and drop it. So then we can just run that over to the gain value on our mixer. And of course, we're going to need our audio out. And so now we can go back into our MetaSound source and drag this in as well. If I wanted, I could flip these around by coming in here, and maybe I want press to be first and numbers to be second, so I can change that sort order to 1 as well. And now if we look here, all right, I've got my press on top and my numbers underneath. So to test this, I'm going to go ahead and take my input and run it to press, my audio out, and I do need to mess with this as well. I'm going to create a graph input for this, but just to test. So that's going to play whatever is in index 0. But I can also create a graph input here and say I then change this number to 5. And so you can hear that that was a completely different tone based on the index that we're picking. And which is why, like I said, you want to make sure that your indexes are aligned between the two arrays in conjunction with the chart that I had showed you earlier. And so with our MetaSound patches done, now we just need to configure our MetaSound source. So I'm going to move our onFinished out of the way and our onPlay. And since we have 4 MetaSound patches that are all mono, I'm going to get a mono mixer 4. And we can run these here. And so now we need to start setting up our graph inputs. And so the first thing that we want to happen is we do want our dial tone to start. Now, once we get here, this is going to be kind of dependent on how you're utilizing this in your project. So from this point forward in the tutorial, the tutorial itself may not align with exactly what you're trying to do, but this should still kind of give you a good understanding of how this is going to work. So for me, I want, when I activate this MetaSound, I do want to automatically start my dial tone, but maybe I want the ability to also just turn the dial tone on with a different function. And so I'm going to come out of here and do a trigger any. I just need a trigger any 2. And so that way I can start it on play, or I can tell it to turn back on. And it would help if I actually use the trigger any the way it was supposed to be used. And we're actually going to do the same with the off. You know, I want to be able to call when I turn the dial tone off. But I also want the dial tone to stop when I press one of the keys, because that's how the phone functions anyway. And so turning it on and off could be activating the MetaSound itself, or we can tie that to maybe picking up or setting down the receiver part of the phone. That would also turn the dial tone off. And so I'm going to leave this open for now until we get down to our button presses. But I am going to give these specific names. And mainly, I'm going to make them correspond with this. So for our on, I'm going to call this dial tone on. And for the off, we're going to do the same. For our busy signals, we can actually just drag right out of here and make these graph inputs, and that will be sufficient for that. And the same applies to our ringout tones. Now for our button presses, I do already have this variable here, which I am going to set that back to 0. But we already have that created, so we don't need to worry about that. And we can drag off here and make this press a graph input. But like I said, I do want my button press to also be turning off my dial tone. And from here, the last thing that I'm going to do is I'm going to create another input. I'm going to make this a trigger. And I'm just going to call this trigger hang up. And that hang up trigger is what we're going to be using to call our on finish. That way, when we hang up the phone, none of this works anymore. Now, here is where the tutorial gets really ambiguous, because as I mentioned before, how I'm setting this up in the tutorial might not be the way that you're setting it up in your project. And for once, I do actually have a really good example of that. So for just an overview sake, my blueprint for this tutorial is set up very differently from how I'm handling it in our upcoming game, Don't Fret. So even though it does seem to be functioning in the exact same manner, in the overall context of the game, it is implemented a little differently. In the tutorial, I'm just using a static image with an overlay. In Don't Fret, we're actually pulling the player into the phone and letting them interact with the physical phone. But I will go into a little bit of depth and just kind of show you the behind the scenes of how I have this set up. So this is just a static image, and if I move this out of the way, I do have a physical phone in the room here, but because this isn't a model I created or had commissioned, these buttons don't actually work. This whole front face is just a solid piece. This is all pointless, but I did want to show you that this is a little different. So I did use a camera to capture a screenshot, and then I'm just doing an overlay. So I've got my background that is just that image of the phone, and then I've got my buttons. So I've got buttons for each of the numbers, and then I've got a larger button here just so you can click on the receiver to pick up and hang up. Now inside my graph, I do have these buttons named appropriately. So button 00 is pressing the button 0 on the phone, and so on and so forth. And I am using my event dispatcher for calling those events. And I did create an input for the digit. And that way, once I get into the actual blueprint, I can pass this integer along that corresponds with that button press. Now to dive into the blueprint itself, which looks a little bit more like a Formula One racetrack, I'm also not going to spend a whole lot of time on this for a couple reasons. One, again, because this is going to be completely different based on your project. And two, I'm still getting acquainted with the programming side of things. So I'm sure there is a far better way to handle what I'm doing in here. I will say, however, that my blueprint is actually loosely based on this Unreal Engine 4 tutorial for a door with keypad from Brian Laley. And so it also just goes to show that sometimes you find the answers you're looking for in the tutorials that you don't even think to watch. Just like we've created a working telephone system using the tutorial for a security keypad. So jumping back over to this giant spaghetti monster, basically all I'm doing is on begin play, I'm adding that widget and doing all the things that you normally do with that. And we're binding events to all of our different key presses. So I'm doing some giant spaghetti logic here. Basically, I have my key presses set up so that they're running through a gate. And I know it's probably a little difficult to see, but I'm using the MetaSound as my target, and we're calling the numbers. And as I mentioned, I am passing through the digit or the number or the integer or the digit that's being pressed. And we're running that digit over into our parameter for our MetaSound. And then that way it's going to tell our MetaSound which number is being pressed and to pick the right sounds from the both high tone and low tone arrays that we had created. And so I'm using a gate because I have it set so that when you pick up the receiver, it will open this gate and allow you to start pressing buttons. Because if you haven't picked up the receiver yet, I don't want button presses to be enabled. And because in our MetaSound we have the button presses turning off our dial tone, that's going to be handled inside the MetaSound itself. And so not only are we passing that digit through to our parameter, I'm adding it to an array so that we're basically creating an array of the number that you're dialing. And so once all of those key presses happen, then we're executing the trigger to press, which is the name of the input that we made inside our MetaSound. And so now I've got just a logic check because I want all of my numbers to be just 7 digits. And that way we can utilize like the 555 and we don't have to worry about, actually putting anybody's phone number into a game. You can certainly change this though if you want to do area codes or, even the country code that'll put it out to 10 digits or more depending on the country code. You can certainly change that here, but since I'm using a 555-0000 format, I only have 7 numbers. So after 7 numbers, I'm going to do a logic check. And so I do already have a variable saved here that has one correct phone number, the 555-8734. You can certainly do multiple logic checks, like say you want to have different numbers that have different messages. You can certainly set those up, but just for this example, I'm just using one. And because we have this set behind the does it equal 7 digits, that means it's actually only going to check our dialed number that we've created after 7 digits. And we've got some true false logic here. So we're going to reset the dialed number so that you can essentially hang up and try again. And if the number you dialed also equals the correct number, that's going to give us our true. And it's going to let this ring out. It's going to turn on the ring out. And it's going to let that ring out for 4 seconds. You could set this to something different. You can do a random, like in range. And then we're turning off that ringer, and then we're playing the answering machine message. This is the only audio asset that's being used. And if this after 7 numbers returns a false, so maybe you dialed something incorrectly, then that's when we're going to turn our busy signal on. And the way that I currently have this set up, I could also add another delay to automatically turn the busy signal off, but I currently have this set up so that the busy signal will just keep playing until you hang the phone up. And then up here, after we've done all of our checks and sets, we're gonna follow this giant racetrack down and around, because what this is actually going to do is run back into our sequencer. And if we follow these lines, what this is doing is it's basically closing our gate so that we can't press any more buttons again. And so now we have a working phone. So we'll go ahead and pick up the receiver, and we'll intentionally dial a wrong number. And so you could hear that we got our busy signal for the wrong number, and we'll go ahead and try again, but this time we'll dial the right number. Hey, you've reached the sound effects guy. I can't come to the phone right now, but if you leave me a message, I'll get back to you as soon as I can. So that's going to wrap things up for this video. Hopefully you found this tutorial helpful. If you'd like to see more, make sure you hit that subscribe button along with the notification bell so you never miss out on any future content. And if you'd like to be part of the Sound Effects Guy Discord server, you will find a link in the description below. Oh, I gotta go. Make sure to wishlist Don't Fret on Steam.